Today's question is, let A equal to 3 by 3 matrix. The first row is 2 0 1, the second row is 1 1 0, and third row is 1 0 1. The B matrix is B1, B2, B3, where B1, B2, B3 are common matrices, and A B1, that means the product of A B1, that is 1 0 0 column wise, then A B2 is 2 3 0, and product of A B3 is 3 2 1. If alpha equal to determinant of B and beta is the sum of all diagonal elements of B, then find alpha power 3 plus beta power 3 value. So what's our question? We need to find alpha power 3 plus beta power 3 value. To find the alpha and beta values, the given condition is alpha equal determinant of B. So that means if you want to find the alpha, you need to find the B value. So first observe the B. B is a matrix of B1, B2, B3. And they said B1, B2, B3 are common matrices, but they didn't say B is a 3 by 3 matrix or 3 by 1. They didn't say anything. Just they given B1, B2, B3, and where B1, B2, B3 are common matrices. That's it. How can you find it? In this case, we have to observe the product of A B1, A B2 and A B3. Let's observe and see. What we given information, A is a 3 by 3 matrix. That we know that. And B we don't know. We need to find which matrix is this. And also they given A B1 is a, which type of matrix is this? So it has 3 rows and 1 column, isn't it? So we can write this as a 3 by 1 matrix. So A B1 is nothing but 3 by 1 matrix. Now let's recall the matrix multiplication condition. Suppose if we have a matrix A has dimension m by n. Here m represents number of rows and n represents number of columns. Suppose if we have a matrix of dimension m by n and also B has n by p. Here n represents, the first one always represents the rows and the second one represents columns. So if we have a matrix like this, the product AB is defined when the number of columns in the first matrix, A is equal to the number of rows in the second matrix B. So that means if these two are equal, then the resulting product matrix will have dimension of m and p. So the result will be m by p. So using this matrix multiplication condition, we will go and find the dimension for the B1 matrix, because we don't know the B1 matrix. They said only B1, B2, B3 are common matrices. That's it. They didn't mention the dimension. And we know only the A matrix dimension is 3 by 3. And we know the product of the result is 3 by 1. But we don't know the B1 dimension. So using this condition, I'm going to find the dimension of the B1. So let's take this condition. In our question, the given matrix is 3 by 3. And we don't know the B1 matrix. So we know only the product of the A B1 matrix is 3 by 1. Isn't it? Our resulting product will have dimension this 3 and here column. Isn't it? So we know that the resulting matrix is 3 and 1. That means here column should be 1. And here number of columns is equal to the number of rows. That means here it comes 3. According to matrix multiplication condition, we got this. So B1 matrix as a 3 by 1 matrix. And the given condition, B1, B2, B3 are common matrices. If B1 has a dimension 3 by 1, B2 also has dimension 3 by 1. And B3 also has dimension 3 by 1 because these three are common matrices. That's why I'm going to consider B1 as a 3 by 1 matrix. Just let us assume ABC and B2 as a DEF and B3 as a GHI. And we know that AB1, the result is 1 0 0. Here we know the A matrix and we know the resulting matrix. So using these two, let's go and find the B1 matrix. Now let's do multiplication. 2 times A, which is 2A, plus 0 times B, which is 0, plus 1 times C, which is C. So that is equal to the first row, which is 1. Now let's do for the second row. 1 times A, which is A, plus 1 times B, which is B, plus 0 times C, which is 0. So that is equal to the second row, which is 0. So from here we can say that A equal to minus B. Now let's see for the third row. So 1 times A, which is A, plus 0 times B, which is 0, plus 1 times C, which is C. So that is equal to 0. So from here we can say A equal to minus C. So A equal to minus C, substitute in this first equation, then 2 times A is nothing but minus C, then we have plus C, that is equal to 1. 2 times minus C, which gives minus 2C, minus 2C plus C, which gives only minus C. So if you multiply both sides by minus, then we are going to get C equal to minus 1. So if C equal to 1, substitute here, then A equal to minus of minus 1, which is plus 1. So the A value is 1. If A value is 1, you can substitute here. So A value is 1, that is equal to minus B. So then after multiplying both sides by minus, then we are going to get B equal to minus 1. We consider B1 as a B, C. So the A value is 1 and B value is minus 1 and C value is minus 1. So this is the B1 matrix. Same like that, we are going to find the B2 matrix. We know that A, B2, the result is 2, 3, 0. So let's take A matrix. And we consider B2 matrix as D, E, F. That is equal to 2, 3, 0. So let's multiply. 2 times D, which is 2D, plus 0 times E, which is 0, 1 times F, which is F, that is equal to 2. Next, second row, 1 times D, which is D, plus 1 times E, which is E, plus 0 times F, which is 0, that is equal to 3. Now let's do the third row, 1 times D, which is D, plus 0 times E, 0 only, 1 times F, which is F, that is equal to 0. So from here we can say D equal to minus F. So this D equal to minus F, you can substitute in the first equation. The first equation turns into 2 times D is nothing but minus F plus F, that is equal to 2. So now we know that F value is minus 2. D equal to, here D equal to minus F, that is minus of F value is minus 2. So that means minus into minus plus, so the D value is plus 2. Substitute this D value in the second equation, which is D equal to 3 minus E. So we know that D value is 2, that is equal to 3 minus E. So then both sides, if you do the minus 3, here we are going to get minus 1, that is equal to minus gets cancelled, minus E. If you cancel these two minus, then E value is 1. So now we know the B2, the value, that is D, E, F, the values are 2, D value is 2, E value is 1, F value is minus 2. So this is the B2. Now let's find out the B3. 3 by 1 matrix, which is G, H, I. That is equal to 3, 2, 1. Now let's multiply. 2 times G, which is 2G, plus 0 times H, which is 0, plus 1 times I, which is I, that is equal to 3. Next, second row, 1 times G, which is C, plus 1 times H, 0 times I, 0, that is equal to 2. Then third row, 1 times G, plus 0 times H, 0, 1 times I, that is equal to 1. So from here we can write this G equal to 1 minus I. G value substitute in the first equation. So 2 times G is nothing but 1 minus I plus I, that is equal to 3. If you open the brackets, 2 minus 2I plus I. So 2I plus I, which gives minus I, that is equal to 3. If you do minus 2 on both sides, here minus 2 plus 2 gets cancelled. So we left I equal to minus I equal to 1. So if you multiply both sides by minus, then we are going to get I equal to minus 1. B3 is nothing but G, H, I, isn't it? So that means we got the I value, which is minus 1. Now we need to find G and H values. So we know that I value is minus 1. So this I value substitute in the third equation. So G equal to 1 minus I. I value is, we know that minus 1. So just directly write minus 1. So here minus 10 minus plus 1 plus 1 which is 2. So the G value is 2. G value is 2. Now we need to find the H value. So now G value substitute in the second equation. So G value is 2 plus H, that is equal to 2. Then H value is 2 minus 2 which is 0. H value is 0. B is nothing but B1, B2, B3. We got B1, B2, B3 values. So let's write it. So what is B1? B1 is 1 minus 1 minus 1. What is B2? B2 is 2, 1 minus 2 minus 2. What is B3? 2, 0 minus 1. 2, 0 minus 1. So finally we got the B value. And now what they given if alpha equal to determinant of B. So if you want to find the alpha, we need to do the determinant of this. So let's do with the first element which is 1. So this is the first row and this is the first column. If you cancel, then what will 1, 0 minus 2 minus 1. Then minus 2 into, you have to close the first row, second column. So then you will get minus 1, 0, minus 1, minus 1. And the last plus 2 times. So now you have to close the first row, third column. So you left minus 1, 1, minus 1, minus 2. What is the determinant for the ABCD? AD minus BC. So now you have to do cross multiply. 1 times minus 1 which is minus 1. And 0 times minus 2 which is 0. So then minus 2 times minus 1 times minus 1 which is only plus 1 minus 0 times 0 which is 0 plus 2 times minus 1 times minus 2 which is plus 2 minus 1 times minus 1 which is minus 1. So minus minus plus, so it's going to be 2 plus 1 which is 3. 3 times 2 which is 6 here. Here is 2 times 1 is 2 and here 1 times minus 1 which is minus 1. So minus 1 minus 2 which gives minus 3. Minus 3 plus 6 which gives only 3. Determinant of B, the value is 3. So this is the alpha value. So therefore alpha equal to 3. Now we need to find beta value. So what is beta? Sum of all the diagonal elements of B. So you have to take the only diagonal elements sum. So you have to take only this sum. So 1 plus 1 plus minus 1. 1 plus 1 plus minus 1. So finally we got alpha and beta values. So now we need to find alpha power 3 plus beta power 3 value. So what is alpha value? 3 cube plus what is beta value? 1 cube. 3 cube is nothing but 27. 1 cube is nothing but 1. So that is equal to 28. That's it.